Welcome to Mathematics with Tom. I am Tom, and today we're going to look at an example of circular and harmonic motion. So I've written this problem down. I'm going to read it to you, and then let's see what it's showing us. It says, a system has a radius 2 and circular frequency of 1 hertz. The particle starts moving at the angle of pi over 4. Find its x-coordinate, a cosine of omega t minus alpha, and when the point first touches the x-axis. Okay, let's do this. I want to draw a picture here also to help explain what we're looking at. So say I have a circle here. Let me give it some coordinates here. Let's do this. Okay, and then let's put a circle on this. That circle tool is amazing. Okay, there. Now, it says that the system has a radius of 2, and let's see, circular frequency of 1 hertz. We'll talk about that. The particle starts moving at the angle of pi over 4. Well, let's draw that. So that means that I have a particle here that starts out right there. That is my particle. I probably should have made it in a more bold blue there. That's better. Okay, so that is where my particle starts its journey. It's in circular motion, and we have, and this is the angle of pi over 4 that it starts at. So the question then is first to remember then that the x-coordinate of a circular motion is represented by cosine of the exponential, and the y values are represented by the sine function. So what we're going to do is just represent the x part of the circular motion as harmonic motion cosine omega t. Well, here we go. Let's try this. So first off, we have that a cosine of omega t minus alpha, and we need to figure out each of these pieces. The very first one is that a is 2. A is just the radius of the circle, so a is 2. Now the rest of this requires the work, and let's do that. So the first part is it says a system has a radius of 2, circular frequency of 1 hertz. So remember that, so frequency is 1 hertz. Well, what is a hertz? Hertz is the number of periods per unit. Oh yeah, number of periods. Yeah, periods of cosine per unit of time. And believe hertz are in seconds, so per second. Okay, well, so if we have 1 hertz, well, remember this is the frequency is equal to 1 over the period. Okay, well, it says that this is 1 hertz, and what do we have? We have 1 period, so this is just going to be 1. And then the t, remember that t it's 2 pi over omega. So if I flip and multiply this, I have omega times 2 pi. And so this is 1 cycle per second, you could say. This is one period per second. Second. Now, if I want to figure out what the circular frequency is, or the harmonic frequency, the harmonic frequency, omega, well, I just multiply by 2 pi. And so I could say then omega is 2 times pi. Okay, so now we can build up our next piece. We have omega equals 2 pi. Now, here's where this becomes a little bit more interesting. And I'm going to write what we have, and then we're going to figure out what alpha is. So if I write this, I have, so far I'm at the point that this is cosine is 2 times cosine of omega, that's 2 times pi times t minus alpha. Well, the question here is whether alpha is plus or minus pi over 4. And that actually requires a little bit more thought. So here we go. Okay, so whether alpha is plus or minus. Well, let's take a look. If I was to just draw a graph here of cosine. Remember here I have 2 pi over omega, and this is, here's pi. I'm going to write these down below. This is 2 pi over omega. And then here, this will be pi over omega. But remember this, omega is 2 pi. So in other words, this is really the value of 1/2. And 2 pi over omega, that's 2 pi over 2 pi, that's 1. And if we continue, if we have pi over 2 pi, that's going to be pi, that's the pi's will cancel, that's just 1/4. So this is 1/4. So when we think about our normal cosine function, what we have is well, in this case, it's going to go up to a, it's going to go down to minus a, and it's going to look like this. So it's labeling some of these key numbers that we are after. Okay, now here's where it gets more interesting. So if we take a look, let's factor this. This is the same as 2 times the cosine of 2 times pi times t minus alpha over 2 pi. That is where the offset is going to occur. Well, if this particle starts at pi over 4, notice if this wasn't adjusted for the frequency, then this particle is starting, say, right here. This would be on a normal cosine curve. This would be pi over 4. But in our case, this is pi over 4 over 2 pi. This is 1/8. Well, wait a minute now. So when my particle starts its journey, it's starting from right there. But where does this journey begin? It doesn't begin at 1/8 or pi over 4 over 2 pi. No, it begins at 0. That's when this whole the system starts. So what do I need to do? I need to shift my cosine curve to the left. So to make it to the left, this needs to be a minus alpha over 2 pi. So this becomes, I can finally rewrite this as 2 times cosine of 2 pi times t minus, well, alpha is pi over 4, and minus that, so it's going to be a plus over 2 pi. And I think we have just enough battery to finish this. So you would write our problem as 2 times the cosine of 2 times pi t plus pi, there's a pi there, pi over 4. That would be my equation to model the movement of this particle starting at that advanced location of pi over 4. So then the final question is, when does this particle touch the x-axis? Well, we're traveling, remember, in the counterclockwise direction. So we're going to hit the x-axis over here on the left, the minus values. Well, when is cosine minus 1? It happens at pi. It happens at 3 pi, because then 2 pi, this is 0, 2 pi, 4 pi. So this would be 5 pi. So in other words, this particle first touches the x-axis when the argument is equal to pi. The argument is 2 pi t plus pi over 4. When that is equal to pi, that is when our particle touches the x-axis. So now what we do is we can say that when 2 times pi times t plus pi over 4 equals pi, that is when our particle first touches the x-axis. So let's see, let's subtract pi over 4. So I'm going to have 2 pi t equals, this is going to be a 3 pi over 4. So if we keep going, we're going to divide both sides by 2 pi, so we can say that t is equal to 3 over 8. 3/8 of a second that pi will then be, that their particle will have traveled and touched the x-axis. I hope that helps. Thanks for watching.